NASA is gathering the press at the Johnson Space Center to name the 4 astronauts flying on the Artemis 3 mission. For years, the agency marketed this specific flight as the one, the mission that would finally put human boots back in the lunar dust. But NASA leadership recently tore up that flight plan. The 4 astronauts selected for Artemis 3 will not touch down on the lunar surface. The program itself is entirely intact. Instead, mission planners have rewritten the schedule to prioritize a different, highly sensitive orbital maneuver. So if this crew is launching into space in 2027 without a landing trajectory, what exactly are they doing up there? Artemis 3 has been converted into a high-stakes practice run. Engineers identified a mechanical hurdle so dangerous they refused to test it for the first time in deep space. The Apollo missions were entirely designed and built under one roof. The Artemis program relies on a web of distinct commercial and public partnerships. This image shows NASA's Orion capsule. It serves as the primary transport vehicle to carry the crew safely off of Earth and into space. Orion is built for deep space transit, not surface operations. To get down to the moon, astronauts have to physically transfer mid-flight into a separate commercial human landing system. One option to catch them is SpaceX's Starship, a massive, towering rocket being developed in South Texas. The competing alternative is Blue Origin's Blue Moon lander, which requires an entirely different set of operational procedures to navigate. The entire Artemis timeline depends on taking these completely distinct spacecraft, built by different companies, and successfully locking them together in the vacuum of space. NASA is already preparing the 4-person crew of Artemis 2 to test Orion's navigation and life support during a flyby of the moon. Once that succeeds, Artemis 3 takes the next step. But instead of flying straight to the moon, both the Orion capsule and the chosen commercial lander will launch and remain in low Earth orbit. This animation shows their primary objective, orbital rendezvous. They must align 2 massive vehicles moving at thousands of miles per hour, perform a mechanical mating process to create an airtight seal for crew transfer, and finally, safely disengage and push away without causing structural damage. Doing this for the first time 250,000 miles away offers zero margin for error. If the docking mechanism jams out there, the crew is stranded. Keeping this test right above our atmosphere provides an immediate abort option. If something fails, the crew can drop straight back to Earth. Artemis 3 had to become a mandatory proving ground before anyone attempts a deep space transfer. Assuming the orbital test goes smoothly, the actual moon landing gets pushed to the Artemis 4 mission, currently targeted for late 2028. This high-resolution satellite map shows NASA's target destination, the lunar South Pole. It is a treacherous, heavily cratered region, highly valued for its trapped water ice. Mission planners are not aiming for a quick flag-planting ceremony. They are designing a permanent surface operation built to span hundreds of square miles. The financial commitments reflect this scale. NASA has already issued over $1 billion in contracts for pressurized rovers, cargo landers, and base infrastructure. Constructing and supplying a base of that magnitude requires ships arriving with heavy equipment and relief crews continuously connecting with the surface landers. If the orbital docking mechanisms are unpredictable, the supply chain breaks. A sprawling human presence in deep space requires a flawless, highly repeatable transfer system. Artemis 3 trades the public spectacle of a moon landing for a technical shakedown. Proving these ships can reliably mate in orbit is the specific engineering requirement that makes a sustained human presence on the lunar surface physically possible.